Hello viewers, as this is my first lecture which I will be going to post on YouTube. This lecture is especially dedicated for preparation of the GATE 2021. The section which I will be taking here is the Applied Mechanics and Design section 2, and the module which I will be starting here is the Engineering Mechanics. I myself, Professor Hemant Sharma. My detailed profile is that I am a faculty in Department of Mechanical Engineering in a renowned institute of Indore, that is Prestige Institute of Engineering Management and Research, situated in Indore, Madhya Pradesh. My detailed qualifications are I am at present pursuing PhD from mechanical engineering from Devi Aliyah Vishwavidyalaya, DAVB, IET, DAVB. I have completed my various degrees like ME, MBA in marketing and B from GSIT, SGSITs Indore. And I have qualified various years GATE exams like in mechanical engineering like 2010, 11, 12, 13 and 2020. So the module in the module that is engineering mechanics, the syllabus as per the GATE 2020 to 2021 is the free body diagram and equilibrium, trusses and frames, virtual work, kinematics and dynamics of particles and of rigid bodies in plane motion, impulse and momentum, and energy formulations, collisions, etc. In this lecture number 1, which I have not covered all the part in lecture 1. Therefore, I have divided here in two parts. That is lecture 1, part A. The content to cover are the introduction to mechanics, branches of mechanics, engineering mechanics, classification of engineering mechanics as a subject, introduction to force, nature and class characteristics of force, and last but not the least, resolution and composition of forces. So let us start with the intro. What is mechanics? The introduction part of mechanics. Mechanics is defined as the branch of physics that describes and predicts the rest or motion of any particle subject to various forces. Through reasonable modeling, the engineers have broadened the subject to treat the solid body or fluid under the action of forces that tend to deform as well as displaces it. So students, what are the various branches of mechanics? The various branches of mechanics which deals with the various parts of the engineering are engineering mechanics first, secondly, mechanics of solid, that is strength of material also we can say, and third is the fluid mechanics. Engineering mechanics, what is engineering mechanics? The physical science that deals with the state of rest or motion of bodies under the action of various forces is known as engineering mechanics. Why we study mechanics? This science forms the groundwork for further study in the design and analysis of structures and to solve many problems of engineering. So students, let us move forward towards the various branches of engineering mechanics. There are two broad branches of mechanics, that are statics and dynamics. In statics, we only deal with the rest position. In dynamics, there are the two parts of further parts of dynamics, that are kinematics and kinetics. The kinematic part deal with the motion, that is displacement, velocity, and acceleration part. And the kinetics part deal with the forces which are responsible for the motion of any particle. So let us moving forward towards some of the definitions, like what is statics, that which I have already discussed, that that branch of mechanics which deals with the equilibrium of bodies under action of forces. Dynamics, that branch of mechanics which deals with the motion of bodies. Kinematics, that branch of dynamics which deals with only motion, that is displacement, velocity, and acceleration only. And what is finally, what is kinetics? That branch of dynamics which deals with the cause of motion, that is the cause of motion is always the force. So let us start with the force, which is the exactly the cause of motion. Introduction to force. What is force? The action of one body on another, whether it is a push or a pull, characterized by its position of application, magnitude, line of action, and sense. As you can see here, that there are two forms. That is, one is push from backside, and the pull from the front of the of any object. So, student, moving forward toward the nature of the force. What is the nature of the force? Force is a vector quantity that is having both magnitude and direction, as compared to the scalar quantities, because scalar quantities are those quantities which are having only magnitude but no direction. And what is the formula of force? The formula of the force, and that was given by Newton, is that a force is equal to mass multiplied by acceleration. The unit of force is in SI unit is Newton, which is also expressed like mass. The unit of mass is kg, and the unit of acceleration is meter per second square. So next, moving forward toward next lecture, the next slide of my lecture, that is, what is the characteristic of a force? There are many characteristics of a force. As per there are four characteristics. First is the magnitude. That is, for example, the value of the force 10 Newton, 15 Newton, 25 Newton. The second characteristic is direction, because as the force is a vector quantity, therefore it always has a direction, that is a starting point and the ending point, from, for example, from A to B, or from example from P to Q. Nature. What is the nature of the force? Here we can say that the nature is either push or pull. And in further, when we go move further towards the any member or a link, then we can say that the nature may be tensile or compressive. Point of application. The point of application is always a single point, because the total force always applied on a single point of contact. So students, the next and the last part of my today's lecture is that resolution and composition of forces. For example, a force in one dimension can say, we can say that the force is either in x-axis or y-axis. But a force which is not in either in x-axis or y-axis, then we can say that the force is acting on a plane. That plane can be treated as x-o-y plane, or say in 3D we have three types of planes: x-o-y plane, y-o-z plane, and x-o-z plane. So, for example, a force, we can express a force in a plane like expressing a single force in terms of its component. These components are sometimes referred to as the result part of the force in two directions. If we are taking the force in xy plane, then we can say that the force will be dividing into two components. Its resolution in both the resolution of both the components are in x-axis and y-axis. For example, see in the figure, a force is applied in the direction which is in some XY plane, and the force direction of force is given in the figure, which is in between somewhere, making an angle of theta degree with x-axis. So the OX component of the force F, that is horizontal component of the force X, will be OX is equal to F cos theta. The F cos theta is the resolution of the force in x-axis and x direction, because theta is the angle made by the force with x-axis. And if this force makes an angle theta with the y-axis, then the y component will be x cos theta. This will be clear to you. Exactly. The y component of the force will be Oy is equal to F sine theta. Okay, if we take some example, practical example, that if we have to move a vehicle, that is this vehicle is a toy, not actual vehicle. If a small boy is moving a toy with the help of a rope or a string tied to the base of the uh, car, and the string is making an angle of 30 degree with the horizontal axis, and the force which he is applying is 20 Newton, then we can say that this force, the force because of there is motion occurring in the car, is in the x axis, x direction. Therefore, this 20 Newton is not the exact value of the force, but the component of the 20 newton in x direction, that will be responsible to move that car. And here the, if we make the figure triangle, right angle triangle, here where 20 newton is the force making an angle of 30 degree with x axis, and y component which is perpendicular to x axis, then the x component of that force, 20 newton force, will be 20 cos 30 degree, which comes out to be 17.3, because the value of the cos 30 degree is 0.866, and the y component of the force will be 20 sin 30 degree, which comes out to be 10 newton. That is because sin 30 is equal to 1 by 2. Therefore, y component is equal to 10 newton. And here, uh, the x component will be responsible for the motion of the car, and the car will be in motion only because of 17.3 newtons, not because of uh, by 20 newtons. Okay, is there any query? Then you can contact me. Thank you. Also, please subscribe my channel. I request you all, as this is my first lecture. Therefore, I request all to subscribe my channel. Thank you. Meet you in the next my next part of the lecture.